So we're going to look at the relationship between velocity and displacement in a little bit, spend a little bit more time with that concept. And specifically, I want to find out what is the displacement of this object that has this velocity function between 1 and 6 seconds, and what is the distance traveled. And those are two different questions, even though they look very similar. Let me give you an example. So if we start here and I run in this direction, if I stop here, my displacement is this distance between the point here, and so is the distance traveled. But if this point I turn around and start moving backwards like this, then if I stop here, my displacement is only measured by this distance. This is this displacement. But my distance that I traveled is actually that plus that. So much longer. And I could even go one step further. If I go all the way out here and then all the way back and past here, my displacement is actually negative. It's to the left of where I started. The distance, on the other hand, is all of this plus all of this plus the little bit extra. So we've got to mathematically figure out how to do the difference between displacement and distance. So I'm going to actually erase all this now. Hopefully you're okay with that, and give myself some room. This is the easier question to answer. The reason it's easier is because this displacement is generated by merely taking the antiderivative of velocity. So we're going to do that first. So the displacement between, let's do that again over here. I'm just going to try and squeeze a little bit more room in here. So displacement is the antiderivative, and we're given it's not the definite, it's a definite integral because we know the lower time limit and the upper time limit of this function over the course dt. I know how to integrate this. I think you guys are probably very good at integrating polynomials at this point between 1 and 6. And if I plug in 6, and I'm going to cancel these here for good measure. 2t. Oh, I know I'm trying to plug in 6 here. I keep making mistakes. I guess it's just not my day. There we go. T squared minus 8 times 6. There's my function evaluated at 6. And then I'm going to subtract it. I'll evaluate it at 1. And if I do that, you get a displacement of negative 2/3. So that means that I have a displacement of negative 2/3 between 1 and 6. Now, what is the distance traveled? The distance traveled is if I think about this, I'm going to go back and maybe possibly backwards here. So I need to separate the problem into two pieces. Where does it switch? And it switches when the velocity is 0. So, and I want to not count this as a negative displacement. I basically want to, instead of subtracting, I want to take this plus that little bit there. Maybe a different color would help. So this piece right here is this piece right there. So how do I make something that is negative, which would that would be, because it's going in the opposite direction, how do I make it a positive? I take the absolute value. So really, when I'm finding distance traveled, I want to find the integral of the absolute value of that function between 1 and 6. And absolute values are harder to deal with. Remember, when we're dealing with most calculus questions, we want to change that absolute value into a piecewise function. And the piecewise function switches the switch in a piecewise function for an absolute value is when things turn from positive to negative. So we want to figure out where is the inside here positive. That means we're always going in this direction. And where is it negative? So we're going to put this on a number line, and to put it on a number line we're going to have to factor. So t squared minus 2t minus 8 is equal to t minus 4 times t minus plus 2. So that means that the absolute value can be written as two different equations. It can be written as t minus 4 times t plus 2, as long as t is positive, as long as it's positive, and negative t minus 4 times t plus 2 when it's negative. And when is that the case? Now, if we put it on a number line, let me do a little bit of erasing here so I get some more room. I have t minus 4 and t plus 2. So at negative 2 and 4 it switches. We're not really interested in what's happening out here because our domain is between 1 and 6. So we're only looking between here and here. And t minus 4 is positive on this side and negative on this side. And t plus 2 is positive everywhere here, which means that the function is positive between 4 and 6 and negative between 1 and 4. So it's negative between 1 and 4. So this is going to be between 1 and 4. And it's going to be positive between 4 and 6. So here I've written this absolute value as a piecewise function, and I'm going to now do the integral of that. So I think I need a new page. So I'm going from 1 to 6, and I'm taking the absolute value of t minus 4 times t plus 2 dt, and we've integrated into two pieces, and remember it was from 1 to 4 was the first piece, and from 4 to 6 was the second piece. Let me write that out actually in more mathematical terms. So it's negative t minus 4 t plus 2 between 1 and 4, and between 4 and 6 it was the positive one. So we're going to now rewrite it into two pieces. So between 1 and 4 I have got this expression. That I'm going to integrate, and between 4 and 6 I've got the positive. So to integrate, I'm actually going to multiply it out again, which would be 1 to 4 is negative t squared plus 2t plus 8. That's basically our velocity function multiplied by a negative. And between 4 and 6, it's the original. So at t equals 4 is where the switch happens from moving forward to moving back, or from this case moving backward and then moving forward, because we're going in the negative direction first and then we're coming the other way. And now I just have to integrate and evaluate. So if I do that, the integration looks like this. It's negative 1/3 t cubed plus t squared over 2, so the 2's are going to cancel again, plus 8t going from 1 to 4, and again it'll be t cubed over 1/3 t cubed minus t squared minus 8t going from 4 to 6. And if I plug in my 4s here and then my 1s and subtract them and the 6s and the 4s, I'm just going to write it out here. You could maybe just pause the video and give it a try yourself and then check my answer. So there is the evaluated at 4, subtracting 1 at 6, evaluated at 1, plus, here's the one evaluated at 6. I think I said evaluated at 6 for this one. It's evaluated at 4. And then evaluated at 4 for the next one. And I'm going to subtract that. And my answer is 98/3 meters, which means that that's the total distance traveled. So it's a little bit more complicated when you're dealing with distance traveled. You have to figure out where the velocity is 0, write it as a absolute value equation, and then break it apart into 2 or maybe even 3 sections depending on what's happening in your problem.